Maritime Made on Eastlink TV, presented by Nova Scotia Business Inc., because great things are happening.
An orthotist is a medical professional who designs custom-made braces for many different health and mobility problems people have. At Advanced Mobility Orthopedics in Sydney, Nova Scotia, they're making a custom ankle-foot orthosis, or an AFO, for a patient to improve his walking and decrease pain. The first step is an in-depth patient assessment. After consulting with the patient about lifestyle and goals for living with the brace, the orthotist measures the leg and the ankle area. In order for a cast to be made, a sock is slipped onto the foot and leg to protect the skin, and a cutting strip is added. The orthotist notes or landmarks joints and any potential pressure areas. Fiberglass casting tape is soaked in water and then wrapped around the leg, foot, and ankle. Then the cast is molded by hand to the desired shape of the brace. The cast hardens within 4 minutes. Then it's cut off, cutting down the cutting strip. Scissors are used to cut through the cast sock, and the cast comes off and is inspected. Back in the lab, the sock is removed from the cast, and staples are used to close the cast along the cut line. To reinforce the cast, the technician wets plaster bandage and places strips around the toe area first, then gradually covers the leg, foot, and ankle. The cast is secured in sand to keep it upright. Then a casting pipe is placed in the center. The pipe will be used for handling the positive mold later.
Plaster is mixed, then blended to remove any lumps or air bubbles. The plaster is poured carefully into the cast until it's filled. It'll take about 30 minutes to set. Once the plaster is set, the mold is removed from the sand and secured in the pipe holder. The plaster is stripped away from the cast, and the staples are removed. The fiberglass negative is peeled away to reveal the positive mold inside. At this stage, the foot of the mold is balanced slightly on the bottom so it will stand up. The landmarks are refreshed. Now a plastic dam is stapled to the toe area, that is then filled with plaster. The toe extension is done, so the mold has a full-length foot to form the brace. Once set, the plastic dam is removed, and the mold is ready for modifying. Secured in a pipe vise plate, the orthotist works to form the toe plate and starts to smooth and shape the mold. The foot shape is worked further with a rasp. Small nails mark the location of the ankle hinges and where the modifications will go. Plaster is applied by hand, creating nuances in the shape needed by patients for a comfortable fit, and to define the final shape of the AFO. When the additional plaster is partially hardened, it is worked to fill in any rough spots and remove any extra plaster.
The mold is secured at a new station, ready to be covered in plastic. A nylon stocking is placed over the mold. The stocking is treated with silicone. A molding dummy is hammered on each side of the ankle on the ankle axes where the hinges will go on the finished brace. Another nylon stocking is added. Then a plantar flexion stop is added. This will stop the brace from allowing the foot to drop down. The technician measures the mold and then the plastic he will need to cover it. With the plastic secured to the table, he uses a jigsaw to cut it. The plastic is heated in an oven for up to 10 minutes. It needs to reach nearly 400 degrees to be the correct forming temperature. Working together, the warmed plastic is removed from the oven and is wrapped over the mold. A vacuum pump is turned on to remove air from between the mold and the hot plastic. any excess plastic is cut off. The plastic cools and sets on the mold. Using an oscillating saw, the technician carefully cuts through the plastic to remove the brace pieces from the plaster mold. The front piece is discarded, and on the back is the actual brace. The plastic is medical-grade polypropylene. The brace is cut along the joint line where the ankle joints will be. The technician grinds and polishes the edge of the brace for a smooth finish, starting from a more coarse grind to a finer one. Polishing is also done. This is the first grind and polish before a patient tries on the brace. A fine grind will be done at the fitting.
The brace is ready to be assembled. Using a punch, a small dent is made in the upper brace to indicate the placement for the hinge screws. The brace is drilled to make room for the ankle hinge screws. The lower part of the brace is prepared in the same way. The screw holes are cleaned up with a knife. Hinges are installed between the upper and lower brace. A hex key is used to secure them in place. The hinges allow motion between the leg and foot. Air holes are drilled in the calf area of the brace and heel for air circulation and comfort. The foot portion is traced onto padding material and cut out. The fit is tested. A hole for the strapping is punched, then drilled, and a rivet is hammered in place. Rivet dots are placed on the inside over the rivet and screws to provide a smooth finish. The brace is ready for fitting. The orthotist is ensuring comfort, function, and aesthetics of the brace. Here the brace is marked for trimming for a perfect fit.
For finishing touches, the foot plate is shaped on the cutter. Further trimming is done, and then ground smooth. The padding for the foot plate and hinges are sized. Then the technician applies contact cement thoroughly to each piece and sets them on the fume table. The surfaces on the brace are also brushed with adhesive. It's left to dry for 5 minutes. The padding is warmed in the oven to soften slightly. Then is pressed into the brace, and the excess padding is trimmed away. The other end of the strap is drilled, then riveted in place. For the final fitting, the brace is tested in the patient's footwear to ensure a perfect fit. Most any body part can be braced with a custom-designed solution by an orthotist.